Hi everyone, myself Navyatha, working as Assistant Professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology. Today, I am going to discuss about index data structures and comparison of file organizations. And my overview of presentation includes about index data structures and what are the different types of data structures: hash-based indexing, tree-based indexing, and comparison of different types of file organizations, which we have discussed till now. That is heap file, hash file, right? Clustered based indexing. So whatever the organizations that we have already dealt, we used to compare those file organizations. Let us discuss about index data structures. So indexes in DBMS are the data structures that improves the speed of data retrieval operations on database table at the cost of additional storage space and maintenance overhead. What is the purpose of maintaining index table? What is the purpose? Let us deal this one with a simple example. So let us take our textbook, any of the textbooks. Let us suppose take DBMS textbook. Okay. So without the index page, if I want to search particular topic, that is normalization, I have to start searching from starting page itself. Am I correct or not? Let us suppose take the index table as introduction to DBMS, that is some 1 to 10. Okay. Next, about RDBMS, that is 11 to 20. Okay. Transaction concept, 20 to 21 to 30. Transaction concept. Last one, normalization, 31 to 50. This is what the index page. Okay. So without this index page, if I want to search normalization concept, then it will take more time. Why? Because I have to search from starting page itself. Right. So if I used to maintain index page, then I can go to that particular page number directly and I can search my topic. That means the search time will be less. Okay. So indexes are the data structures that improves the speed of data retrieval. That is what the meaning. Okay. That means whatever the data we want, we can retrieve the data in a fastest manner by considering index tables. Most commonly used index data structures in DBMS are hash-based indexing and tree-based indexing, which we have already dealt. Hash-based indexing means here we use hashing concept, hash function. So hash function is used to generate address. In that particular address, we can keep the records. We can store the records. So hash-based indexing is categorized into two types, which we have already discussed: static and dynamic. And dynamic is also called as extendable hashing or extended hashing. So these topics which we have discussed in our previous sessions, but mainly the index data structures are classified into two types: hash-based indexing and tree-based indexing. Let us discuss hash-based indexing first. We can organize records using a technique called hashing. Right? Hashing means here we use hash function concept. Hash function is nothing but one mathematical function which is used to generate an index or address. Okay? To quickly find records that have given such key value. How we can able to calculate that hash function? For example, it is nothing but a simple mathematical function. This is what a simple mathematical function, k modulo m. Okay. So what is k here? That is nothing but the key values or key attributes. Okay. So whatever the value has been generated, this can be considered as an index. By considering this index only, we can store the records. That is what my intent. So in this approach, the records in a file are grouped in buckets, where a bucket consists of primary page and possibly additional pages linked in a chain. That is what here we have already discussed. See here, let us take one example: SID, SNAME. Okay, some SID, ABC, SNAME, XYZ, okay, PQR. So here I can consider SID as primary key. That is what here, this is what key attribute. Why? Because it has unique values, right, which are not repeated. Okay, but here you can see I can't consider SNAME as primary key. Why? Because ABC, we have repetitions, redundancy of data. So by considering this key attribute, I can generate an index value. That means, let us suppose this is what my hash function k modulo m, where m is equal to 3. Where m is equal to 3. Let us suppose, consider m is equal to 3 and the hash function is k modulo m, where k is nothing but this key attribute SID. So let us find out where to keep. These are the data buckets. Okay, these are the data buckets. These buckets range from, for example, 0, 1, 2, 3, 4, like that. Clear? So now, by considering this hash function, I can able to insert this record. That is, what is k here? Key attribute 1 modulus 3. Right, what is 1 modulus 3? 1. Therefore, this record 1 can be kept here in the place of 1. Right, next 2. 2 modulus 3. Where I have to keep this second record? Second. Why? Because here I have generated, by using this hash function, I have generated 2. Therefore, here I can keep my second record, x, y, z. Okay. Next, 3. This is what my key value. 3 modulus 3, 0. Where I have to keep this record? Where I have to keep? Here, 0. That is ABC. This is what the record 3. This is what the record 1. This is what the record 2. Okay. Next, again, here, let us consider 6 modulus 3. For example, let us suppose, here I have inserted record 6. That is nothing but PQR. The record which I have inserted 6, that is nothing but PQR. Let us think. So, where I have to keep this record, 6th record. Okay. So, 6th record means 6 modulus 3. Okay. So, what is here? 0. Right. So, 0, here I have to keep 6th record, but in 0 already the record is there. Then where I have to keep? Here I can create one more node. Okay. I can link up that one. I can keep the record 6 here. Okay. This is what chaining. That means the bucket overflow. Here the bucket overflow condition occurs. Then we used to add one more node and I can keep and I can link up these two. If at all I want to find out that record, whatever the record, that is 3 or 6, I can go directly to the 0th location by using hash function concept. We can insert the data, we can delete the data, we can update the data by using this hash function. Okay. So, in this way, we can add additional pages linked in a chain. That is what here I used to do. Next, the bucket to which a record belongs can be determined by applying a special function called hash function to the search key. This is what till now I have explained. Hash function. It is simple mathematical function to a complex mathematical function. See, these are nothing but primary key data records. These are the data records. Just now in the previous example, I have explained SID 1, 2, 3 like that. Here I have taken some more records, right? So, by applying the hash function, what is the hash function here? See, h of x modulo 5. By applying this hash function, let us suppose, consider 106 modulo 5. Okay. So, where I have to keep here? In 1. So, at 1, here this is what the hash table. Okay. This is what the hash table. So, at the place of 1, I used to place 106 record. So, in the same way, we must calculate all the hash function by considering hash function. We must calculate for all the keys available. Okay. So, by considering those keys, we can keep the records. If at all it is empty, we can keep them directly. If at all it is not empty, then we can add one more link or node. That is what one of the procedures. And in dynamic hashing, we can split these buckets and we can split the directories also. That is what one more method which we have already discussed in our previous sessions. Next, coming to tree-based indexing. So, an alternative to hash-based indexing is to organize records using tree-like data structure. See, this is what root node, these are internal nodes, some hierarchy has been maintained here. Okay, some levels, some hierarchy will be maintained. The data entries are arranged in a sorted order by search key value and a hierarchical search data structure is maintained that directs searches to the correct page of data entries. So, let us take for example B plus tree, or B tree. Here we used to keep the records in a sorted manner. This is what the root node. So the left side of the root node will be always less than, and the greater side will be greater, and the right side will be greater than, or right. So in this manner we used to insert, or we used to store the records. The lowest level of the tree, called leaf level, contains data entries. All the leaf nodes contains the actual data. Remaining internal nodes will act as the pointers to the leaf nodes. Okay. So here non-leaf pages contain node pointers separated by search key values. So let us see this example. See, this is what the root node. This is what the root node, and here we have per node we have only 2 keys. Per node we have to store only 2 keys, and have to insert the data, and have to delete the data, have to search the data. Let us consider a B plus tree example, B plus tree organization, and in that I used to explain very clearly how to insert, how to delete, how to search the records. Okay. So let us see. Here we have root node 12 and 78. So if I want to search 20, so where it will be available? It is 20 is greater than 12 or less than 12? Greater than. So obviously I used to go here. Okay, greater than 12. If at all it is less than 12, then I used to go for left hand side. If at all is greater than, then I used to go right hand part. Right. So in that way we used to search. That means half of the time will be less. Why? Because I will not search the one part right. I will go for the next part. If it is less than, then I used to part left subtree. If it is greater than, then I used to search the right subtree. So half of the time will be saved there itself. That is why here tree organization, tree structured organization is very simpler, and the time taking process of searching is very low when compared to other organizations, other file organizations. And lastly, here the records are saved at the leaf nodes. These are nothing but leaf nodes, and these are nothing but the address values or indexes, the pointers which act as pointers to actual data. This is what the actual data. These are the original records. Those records will be stored at the leaf level only. That is what tree structured indexing. Next concept is comparison of file organizations. So here we used to see different types of file organizations. So sequential file organization, heap file organization, hash file, ISAM, indexed sequential access method. This one we used to deal in our next session. And B plus tree file organization, this also we used to see in our next session. And last one, clustered file organization. So this is what we have already, these 4 we have already dealt. Sequential file, that means we used to store the elements in a sequential manner, one after the other. Here we have 2 types of sequential file organizations. What are those two types? Pipe file method and sorted file method. In pipe file method, whenever the record comes, then we used to insert that as it is. So in sorted file method, we used to insert the record and we used to sort it. Right? By using any of the sorting techniques, we can use to sort those files, and we have to insert records in a sorted manner. That is what sequential file. Heap file organization. Here we used to deal with the buckets. Right? Next, hash file organization. Here we use hash function. And ISAM, index sequential access method. This is also one type of tree structured file organization which we can able to store the elements in an hierarchical manner. Okay. B plus tree file organization. This is also a tree structured file organization which we can able to store the elements in a hierarchical manner, that too in a sorted order. Next, clustered file organization. So here we use cluster key to join 2 or more tables. We use one key, that is what we called as clustered key. Okay. So these are different types of file organizations. Out of these 6 we have already dealt about. For these 2 we used to deal in our next sessions. How we can able to compare? So heap, unordered. So here we have disadvantages, advantages and the use cases. So first one, let us discuss about heap. So records are stored in order thereof with no specific sequence. Without any sequence, records are stored. For example, see here, this is already existing file R1, R5, R3. Now suppose I want to insert R2, where I can keep, here I can keep R2. There is no sorting, there is no order. This is what heap, right? So, and what are the advantages? Simple to implement, efficient for bulk loading of data. That is what one of the advantages. And disadvantages: slow for searching specific records, not efficient for updates. Okay. So why? Because we have to search sequentially one after the other. So suitable for small data sets or temporary tables, where the application, where these heap unordered organizations will be used for small data sets. Next, sequential file organization. Records are stored sequentially by the value of a key field. Fast sequential access, suitable for range queries, and costly to insert or delete the records, reorganization required. So whatever the records that we used to store, that will be reorganized sometimes. User when frequent sequential access is needed. So where we have to use, if at all we have to do sequentially or frequently the data accessing, then we can prefer this kind of one. What is hashing? Hash file organization. Records are stored based on hash function applied to a key field. So only records are based on one function, that is what we called as hash function. Fast for exact match searches, right? Next, inefficient for range queries and collision needs handling. This is what somewhat inefficient for range queries. That is nothing but if at all I want to find the elements from 25 to 35. So it will be somewhat complex. That is what. User for unique key lookups like user IDs. So if at all I want to search for a particular ID, I can go there and I can search. But range of queries, it will not very that much useful. This organization, hashing. Next, clustered file organization. So what is clustered file organization? Related records are stored together based on a clustering key. That means here, if at all, to join two or more tables, we use one key. That is the common key between those two tables. That key is called as here clustered key. Based upon that key only, we can able to join two tables. So improves performance of related queries, reduces IO operations, input-output operations. And what are the disadvantages here? Complex to maintain and requires careful choice of clustering key. That means whatever the key that we can able to consider as a cluster key, no. Here, if at all to join two tables, the joining must be lossless. We must not lose any kind of information, or we must not get extra information. Whatever the information that we get extra, those tuples are called as spurious tuples. This one which we have dealt in our joins concept. Okay. So, if at all I want to, for example, let us consider ABC. Okay. A, B, B, C. These are the two subtables. So, if at all I want to join these two, by considering only common attribute, I can join. But not just like that. We must join those two. Why? Because we have to consider the common attribute as key attributes. Then only we can able to get the consistent data. That is what here. Suitable for related data queries, example by region. That is, if at all we want to consider or we want to get some employees, for example, those employees belongs to Hyderabad. Okay, those employees belongs to Andhra Pradesh, like that. So we use these kind of clustered file organizations to get a group of data. Indexed sequential access methods, ISAM. Indexed sequential access methods. So records are sequentially organized with an index for fast searches. That means based upon the index values, we can able to insert the records. We can able to retrieve the records. Combines fast sequential and random access, good for range queries and efficient for search. Okay. Next, indexed maintenance overhead. That is what one of the drawbacks. Insertions, deletions may require splitting. So here, which may require splitting. Why? Because here if at all I used to add an element, that node contains only the data records which we have to insert two. One more third element I have to insert. Then that node must be splitted. So here splitting must be done. Common in OLAP systems for reporting and analytics. That is where we have to use application. This ISA. Next, what is B plus tree? Balanced tree structure where all the leaf nodes are at the same level. All the leaf nodes are at the same level and the data, actual data will be resided in the last level, that is leaf level. Efficient for search, insert and delete operations, support range queries. So, if at all here we used to search some of the queries related with some range, that is nothing but I want the IDs between 25 to 35. Then I can use this B plus tree. Why? Because from the root node, I can able to guess where the 25 to 35 will reside. Right? That is what the reason. Requires additional storage for tree maintenance. That's obviously we used to require. And suitable for scenarios with frequent updates and lookups. Whatever we want to see frequently, then it is very much useful. And the time taking for searching also is very less. So till now we have discussed about the different types of file organizations, and the conclusion of this one is choosing right file organization depends on the nature of the data. Whatever the data that we are going to insert, so how the volumes of the data also depends. Okay. So choosing of different file organizations is depends upon your data, the type of queries and the access of patterns. Next, for fast lookups based on the key values, hashed or indexed organizations are best. For fast lookups, that means if I want to get the ID 103, then hash based or indexed file organizations are very best. While for the range queries or the order data retrieval, sequential or B tree structures or B plus tree file organization is very much suitable for range of queries. Next, complex relationships between tables benefit from clustered file organization. Complex relationships between tables means here if at all I used to join two tables and if at all I used to get some data that belongs to department CSE or its department ECE, then that cluster data will be available in that particular table which we have joined from two different tables, that by using clustered key. That can be retrieved by using clustered file organizations. This is what the summary. And till now what we have discussed. So we have discussed about index data structures. Index data structures, we have two types. What are those? Hash based indexing and tree based indexing. Okay, hash based indexing and tree based indexing. Here in hash based indexing, we use hash function. Okay, to maintain the index table or to generate indexes or addresses, we use hash function concept. Tree based indexing is a hierarchical structure. Here we have different types of B trees, B plus trees. These are different types of tree file organizations to store the records in a hierarchical manner. And apart from this, we have discussed about different types of file organizations. That is nothing but comparison of file organizations, their advantages, their disadvantages, and applications. Thank you.